Okay, another type of transformation similar to what we did previously, but yet very different conceptually. Now, y equals to fx, if that is my original function, and I look at a transformation mod y equals to fx. Transformation mod y equals to fx. Will it be same as mod fx? Will the graph look exactly like mod fx? What would happen if I take mod y instead of mod fx? I'm looking at mod y. Will that be same as mod fx? Now, just carefully, okay, very carefully think about these things. Now, in mod fx, what were we doing? For each x value, we were making the y value positive. Wasn't that so? For each x value, I was getting an fx. In case that fx was negative, I was making it positive by taking modulus. Okay? So y comes from x in that, right? Y comes from x. Okay? Now y comes from x in that. But what is happening to this function? What is happening to this transformation mod y? So here what I'm trying to say is that in this transformation, whatever y you might have, you might get a negative y, but you are making it positive, and hence your x's will be different this time. So hence the roots of the equation might just change. Okay, your x's will be different. So y in mod y, for each y value that we make positive, okay, we make y positive, and hence the x value will change. Hence the x value will change. Everything you will be able to understand with this one example that I'm going to do with you. Now, let me take, for example, a quadratic x square minus 3x plus 2, which factorizes into x minus 1, x minus 2. Mod y equals to this. Now, try to understand mod y equals to this. Okay, it's not that y equals to mod of this, but mod y equals to these factors. You understand, mod y equals to these factors instead of y being equal to mod of these factors. So first of all, of course, we will look at the simple y equals to fx, which will be x square minus 3x plus 2. Okay, so what will be the graph of it? Let us just graph it, give it certain values. So of course the roots are 1 and 2. Okay, so roots are 1 and 2 mean, which means that fx equals to 0 at that point. And when will it cut the y-axis? It will cut the y-axis at 2. Okay, y equals to 2, x equals to 0. Okay, and let me take 1 point somewhere in between also. 1.5 when x is 1.5. When x is 1.5, let me use a thicker one. When x is 1.5, again let me just cut it and write again for you. Y comes out to be minus 1 by 4. So you have certain negative y's coming. Now that means that my curve, when I look at mod y equals to whatever fx I have, then this curve will change because the modulus value of y will only be positive. So what will happen essentially? In the case of say y equals to minus 1 by 4, x equals to 1.5, fine. But what is happening is that mod y equals to x minus 1, x minus 2. That's my function in factors. So now mod minus 1 by 4 is essentially 1 by 4, right? Right? Which means that my equation now changes. My equation changes how? My equation changes when I open it up. Basically 1 by 4 equals to x square minus 3x plus 2. Now this implies that actually ultimately the equation that I get is 4x square minus 12x plus 3 equals to 0. So the roots of this equation satisfy y equals to 1 by 4. Y equals to minus 1 by 4, but mod y equals to 1 by 4, right? Y equals to minus 1 by 4, but mod y equals to 1 by 4. So I will get two values of x. I will get two values of x. If you want to try to, find the roots of it, you can of course use the formula minus b square, minus b plus minus the discriminant b square minus 4ac upon 2a, and what you will get is that x equals to 2.72 and 0.27. Okay, so that's what you will get. So for the value minus 1 by 4, for the y value minus 1 by 4, I'm again time and again saying that y is minus 1 by 4, but my function given to me is mod y equals to certain factors or whatever quadratic equation, okay, quadratic polynomial. So this becomes 1 by 4, and it gives me a different answer this time. It will not give me 1.5, it is giving me 0.27 and 0.27 and 2.7. So what is essentially happening is that the behavior of x is, okay, when y is 2, x is 0. When y is minus 2, then also x will be 0, because at minus 2, when y is minus 2, mod y is 2. So x will be 0. So the behavior will be like that this turn that we are having out here in this parabola, okay, will actually get inverted into turn like this, cutting the y-axis at minus 2, and of course as we have this, this will be like this. So as we have a curve like this here, so this point is essentially 2.7 minus 1 by 4, okay, this point. So you understand this is pretty different from what we had earlier in this graph. In this graph, when y equals to mod fx, what was happening was that the y values were turning positive. This time I'm not saying that. What I'm saying is that even when my y value is negative, but what is happening is that when I'm looking at the function given to me, I will get a different x for it, okay? Because the y value in the function turns positive. The y value is negative, but mod y will be positive. So I will get a different x. So for y, I will have a different x, okay?